Hello, welcome to Mix Training. This is Varomix, and today we're gonna be destroying sand castles. Alright, so today we're gonna destroy a castle made of sand. And as you saw in the intro, I also made a test with Roberto, of course, made of sand, and it was pretty cool. But this is what we're going to be doing here. The same techniques, but I just wanted to have a proper castle. So this is just the preview here of what we're going to do. Of course, this part here should be falling. I want to show you how you could be making this fall. I was just I could do it, but I just wanted to make show you the techniques that we're going to use, and then you can just be making this stuff work on your own project. Alright, so this is gonna be really simple. Seems really might seem a little bit complicated, but it is not. It's really simple stuff, and Houdini has all the tools prepared for us to just use it for your project here. So there you go. Here's the scene that I was just showing you, and this is the castle that is already cached. See, here's the scene. It's really nice. I had just a backdrop there, and the ball it's going through the sand castle is blasting away all the sand there. It's pretty cool, pretty nice. We're gonna start really quickly. Let's make a new scene. Let me save this new, and I just copied that castle that I had prepared. I'm just delete all this, and I want to show you what I have to start off. Alright, so I have this castle, and there's a few things that I want to change here. So first I'm going to delete that huge polygon at the bottom. Just delete that one. I don't want to have that polygon there. The other thing is I want this to be sitting on the floor. You can see some pieces are a little bit off the floor, and some pieces are below the ground. So I'm going to just clip this. I'm going to clip this thing just to make it clip up to those pieces here, so everybody is on the same plane. But now I need those areas at the bottom to be closed, so I'm just gonna polycap those. So because that we need to have closed geometry when we convert this into sand object. So now it just close. It doesn't matter how it looks here because this will never be used for rendering, so it's just nice that it's closed. We don't care about the actual geometry there. Alright, so this is prepped now. Actually, one last thing I want to do is just move this guy down here. I'm not just gonna use my transform trick. Just get this guy and just subtract the y minimum value. You can see that just puts it there. That's how I do that. If you want to put the pivot there at the center, just do the y minimum as well. So just basically saying the minimum bounding box in y direction. That's what it's doing, and it just works pretty well. I use that a lot for moving stuff to the ground. Now we're gonna use the grains shelf here, which it's pretty awesome actually, and it's gonna make our work really cool. So I'm gonna use the wet sand because if you're making a castle like this, it should be kind of wet until it dries out. So let's go for the wet sand. So let's just go here, select this guy, wet sand. There it is. Alright, so for some reason it wasn't updating at the first frame, so there it is. But you can see there's some pieces that are not showing. This is because the model it's really low res, so we need more actually more particles, less separation here. So let's put this to 0.05, not 5, maybe 8. I would just want to see the wall. It's gonna be here. To rewind to frame 1. I still don't have this wall here. Let's see what's happening with that wall. That wall, is it capped correctly? Let's see if it's capped correctly. No, it's not capped correctly, so let's see what happened there. So it's not close in this area. Let me just move this guy a little bit higher, and let's try with a single polygon again. There we go. Now it's closed. Okay, so just make sure, just had to move my geometry a little bit so it's close at the bottoms there. So just make sure that your geometry is closed properly, so you can get those walls to be represented correctly there. Alright, so now that the geometry is good, we can see it, the grains are okay here, and we're going to work for now with this coarse geometry to start off. Now let's make just a sphere. Alright, so I just made a polygon sphere here, and I place it over here, and I place it on the floor. And now I'm just gonna give it a velocity with a wrangle. So the expression needs to be, I'm gonna set it to 0 on x, 0 on x, on y, and 20, let's say 15 on c, and set that's gonna be the velocity for that. All right, so now we have this ready. Let's make this rigid object, RBD object. There we go. Should be already here. There it is. Now let's create a collision for the floor, ground plane. There you go. L for to show everything here, to lay out everything. I don't want to see the floor either here or here, so I just want to hide it. I just want to react. So alright, so this is the preparation part, and now we're gonna start just playing this. And the first thing you see is the castle is just collapsing. It's doing weird stuff. It's kind of wiggling and stuff. And that's the effect of being wet sand. It's clumping, but it's kind of trying to fall. The ball is just there. It's kind of moving a little bit because it's not perfect. So let's go and do a few things. Alright, so here we want the ball to actually be a sphere. So just change this to a sphere. You don't want to calculate anything, just make it a sphere. Also, this, you can see this guy is not moving, and you will think that you will go here to the initial state and enable the inherent velocity from point velocity, and that's correct. But if you see, if we play here, the sphere is still not moving, and that is because if you go back to the sphere here, the ball here, when we set these pack primitives, we're not passing the velocity to it. You can see here there's no velocity. Here there is a velocity, but here is not. You need to transfer the attribute here to the actual primitive, and now there it is. And now here in DOPS it's gonna be working. Right now we are inheriting that, and now you can see if we play, this guy's gonna move, and it's going to collide with the castle right now. So this is already kind of doing what we want, but we now need to control when this castle wakes up or when the particles wake up, and that's exactly what we're gonna do. You can see this is already splitting the particles apart, but we don't want this castle to move until the sphere collides with it. So here, go to the pop solver, and there's a sleeping area here. Enable that and enable start asleep. And that means that when you play, the castle just not gonna move at all. You can see that it's not even reacting to the rigid body, and that's because the particles are basically sleeping or inactive, let's say. And there is an option to wake them up. You could wake them up with attributes and stuff, but Houdini has this really nice tool in the grains tab that it's already set up here, and it's awaken by geometry. So let's go up and say awaken by geometry, select your ball, or here, press enter. Now what that did is just this simple node here, created this node with this really amazing icon, and source that ball there, created a few nodes on the ball, actually this you guys, and this null, and this just creates a volume of a VDV of it, and it's gonna be used here to wake up the particles. Now if we rewind and play, Now you can see this is exactly what we wanted. The particles, only the particles that are colliding with the sphere are being woken up and are reacting with the sphere here. And basically, if that's all you wanted, that's it. You are done actually. But when I was doing this, I discovered a few gotchas, and I'm gonna tell you about them in a second. So it's going through the castle and it's spitting sand all over the place, which is cool and all that stuff, right? So let me reduce this a little bit more because we don't need that stuff. It's just already gone that time. It's that amount of frames is enough. So we are reacting with the sand, and we're leaving a huge trail of particles and stuff, which is pretty cool. But now there's a few things that you should know. Now if you go to the grain solver and say, alright, I want my particles, so one of the things is the particles slide a lot in the floor. So if you can see a little bit here, the particles keep sliding a lot. They're going on the floor and they keep sliding and sliding and sliding and sliding. And that's not how sand behaves in never in any situation. So go here and I just make this static and kinetic scale all the way to 10, and that gets rid of that. And another issue is when you have this amount of particles, it's all good with the sphere. But since these two are affecting each other, so the sphere is waking up the particles, but also the particles are affecting the velocity of the sphere. If we have a lot more particles, you can see right now the sphere has no problems going through that amount of particles. But when we go and put more particles, let's put the separation back down to 0.03 maybe. Now we have a lot more particles here, and that's too much actually for our test. Put 0.05. Now if we play this, a few things could happen. The sphere could stop because there's so much force being emitted from the resistance of the particles, and also there could be some issues that I found really weird, but I found a really nice workaround. Now you can see there was a big jump right there, and that's the issue I wanted to talk to you about. Like you can see from this frame to this frame, that was a total error there, and you can see home particles here are not even being affected there. So there's some issues with the substeps there, and as I was doing then I was making the substeps higher, and that wasn't actually working for this. So one of the things is that, and if you make this even lower, let's try 4, maybe we can see it. Alright, so it didn't happen here what I was expecting, but sometimes the previous issue happened. You can see the ball flied away really fast, like it went from this frame to this place and then just flew away. But sometimes even if you have a bit more particles, the ball actually bounces back because there's so much particles that the ball can't move them. So to solve that, if your ball it's actually being thrown back by the particles, go to your ball and in the physical area tab, I'll just put like a 10,000 from the density, and that's just gonna be enough to move the particles. And I just did something weird here, which is not what I meant to be doing. And now the other thing that I found is that if we go here to the substeps, you can see the substeps is 10 minimum and the maximum is binded to this, and this is really problematic. I don't know why, but what I found the best settings for this are just put 3 here and 6 here. And I tested a lot of settings. I tried doubling these values and everything fails. So just for now, go for that. If you find other settings that work, do use those. But for me, as I did a bunch of testing, 3 and 6 are probably the best settings. If you have these two values of the same value, it doesn't work at all. So now you can see this thing, it's going through the sand, every frame is being calculated, nothing is being jumping or is not failing at all. So 3 and 6 are the magic numbers here for now. Alright, so you can see this is working exactly as we wanted, but now you can see the ball is pushing the particles. Really cool. So let's lower the resolution, and I'm gonna show you some more stuff here. Let's put it back to 1, and now you can see this awakened ball. Right now you can see only the particles that are being touched are being awakened, and that was one of the issues when you saw in the previous one I did, that the area here, it was like flying there, like it shouldn't be doing that. It shouldn't happen like that. So that right now what this node is doing is creating a volume, or getting the volume that it's created in the ball geometry, and it's just saying whatever touches this volume, it's gonna be awakened right now. So that's why all the particles that are going here in front of the ball or around the ball are being awakened, and then just collide and react like the grain particles. But this area here is the pretty cool part of this, is the self-awakened part. If you enable this awakened by nearby particles, it's gonna say that if particles get a higher velocity than 1, they are gonna be awakened. And this is kind of this wake up scale. Just think about kind of like a radius, like how far it's this gonna spread around. So if any particles have velocity higher than 1, they're gonna be awakened. And now you can see you're gonna have this kind of volume that gives you kind of feedback, and it's awakening the particles. So it's creating another volume on top of this, and it's awakening those particles. You can see every particle that's being touched by this volume, it's being awakened. But if we lower that value, if we say, alright, if the velocity only needs to be 0.1 to you, so particles awake, you can see now more particles are being affected, because this particle is saying it's touching the other particle and it's giving it velocity, and it's awakening the other particle. So it's kind of spreading the awakened attribute. You can see this is pretty cool here, how the attributes are actually spreading to the whole tower here. And this is what we need to do for this tower to actually fall, because in my other example, the parameter or the awakened attribute was not going all the way up here, and this part just kept floating there. So I needed to expand a little bit more this attribute, so it goes all the way up, and this react as you need. But also it might look a little bit too wobbly. It depends on the scale of your scene. You can see right now it looks a little bit too wobbly, and the scale, it's a little bit seems too small. So just play around with this, and maybe you can even activate that area by yourself. So you can see now if I put more velocity here, it's gonna take more velocity of the nearby particles to wake up everything else. So it's not gonna spread as much all over here. And this grid spacing here is basically just saying, it's basically the quality of this volume here that it's being created. So if you make this really low, the voxel is gonna be really low. But now you can see the velocity, it's not spreading so much here, it's just spreading around here. So it just depends on what you need, on what your project's gonna be, and how you want to do this effect. And with that, I think we are done with this. Yeah, it's pretty simple stuff. I didn't touch any of the rigid body solver substeps or anything like that. There's no need for that. Also, maybe another thing that it will be cool to have, it's a pop drag, so particles don't go flying away like crazy. Always good to have a pop drag every time you're doing particles, just put a pop drag, they will look a little bit more natural. The other thing is I'm gonna tell you here, since you are animating, actually simulating a ball and simulating sand. If you go to the grain particles here, you are just importing the ball. You can see there's, I mean, the sand here. It's just importing one object, and if you cache this, it's just gonna cache the sand, and you're gonna be missing the ball because the ball is actually being simulated, and it might be stopped by the sand. If it's not dense enough, it will be. If you could get it in the middle of the model, if your model is more dense, you could get stopped. So if you go then later and try to cache this sand, this ball object, you're gonna simulate the sand again just to get this simulated ball there. So what I did, instead of doing 2 caches, well, instead of that, I just, in this same import, I just added another one other field here, and just say ball here. And now I'm importing the ball and the geometry here in this node, and I can go and use this save to file, and I'm gonna cache once, and I'm gonna save both objects, and I'm sure that I can just get them by name or by group or whatever, and do whatever I want with the ball and the castle separated. At the end of your cache, if you are just having a cache, there's an appressed sand object there. You can see it in my other scene that it's already cached. Here's the other scene that it's already cached. Go to these guys. You can see that this guy actually, it's not actually simulated at all. So let's go to that grain stuff. If I say this appress.sand, I just selected this and then click this icon here. So this is just a point replicate node with some other nodes that just duplicate sand around this, but it's not being simulated at all, which is cool because if you already have this simulated, you don't have to simulate again to appress it. I wouldn't give all the credit for or use this method just to appress the nodes, because it's just actually copying more particles around the particles you already have. So this is what happened. Let's go inside here. You can see my default geometry is this. This is my default geometry. I have what like 1,000,000 points, and then it creates like 10 times that here, and it creates a few other nodes. You can see now here it's 11 million. So again, just creates a few attributes, duplicates the points here. You can see it's just for every particle, just creating more particles on top of that particle, actually 10. So it's cool, and it creates a little bit more kind of a sandy feeling, and it creates a few other attributes here like the P scale. It looks pretty nice actually, but don't rely on this for the quality. Try to get as much of your object from the simulation, and then just appress it for an extra push towards this. You can see it looks pretty nice. Really looks like sand. Alright, so that's gonna be it, guys, for this. It's a really simple effect. It looks pretty complex. It's really simple using the tools that Houdini has for us. So alright, guys, hope you like this, hope you enjoy this. Share it with your friends. If you haven't subscribed to the channel, please do so. Click that like button, and let's keep learning together, and I will see you guys in the next one. Cheers.